Hello friends, so today I'm going to discuss about SSH. So first let's discuss the full form of SSH. SSH stands for Secure Shell. So S stands for Secure and SH stands for Shell. So what is the need of this SSH? So we will discuss about it. First discuss about this term secure. What do you mean by secure? Secure means anything that is encrypted. Anything that is encrypted. And shell, what do you mean by understand by the shell is the word that is taken from Unix. In Unix, shell means CLI stands for command line interface. CLI stands for command line interface. Now let's combine those terms. Secure means encrypted and shell means CLI. So we are getting a secure CLI. So anything that is performed in CLI is secure between device and the management station. Management station. This means let's take an example. Suppose this is my management station. This is a PC and this is my device. Suppose I am taking a router and in between I have a network of ISP. So I am taking the CLI of the router on my screen. Here I will see the CLI. Here I will see the CLI. Now what will happen if my this configuration, what I am doing on the CLI will be gone to the router. We need to create a secure path. We need to create a secure path between this PC and this router. That is achieved by the SSH. We have many more terms like VPN. We cannot discuss here because our main focus is SSH. So if we want to take a CLI of a device and we want to make it secure by encrypting all the configuration, what we are doing it and what is the password of my device, so we will use SSH. Now SSH was developed in 1995. There is a person Ketu. He is the person who introduced this protocol. Why he introduced? Because Telnet is unsecure. Everything is in plain text. So we will find out how. Let's take an example of this is our there are two routers R1 and R2. The R1 IP is show IP interface brief 12.1 on F0/0 which is written F0/0 12.1. R2 IP is 12.2. So I have a basic reachability. I can ping. Now if I want to configure Telnet, that is line V device 0 to 4. Password is Cisco and if someone try to log in, this means my password is Cisco. When someone try to log in, ask the password Cisco. So from here if I type telnet 12.1.2, it will ask the password Cisco. I get the access. In the backend I'm capturing the packet through a tool that is called Wireshark. I just need to click on the any protocol. Sorry, I need to just click on the any packet that is running Telnet protocol. So there are many packets, just click randomly on the Telnet, analyze, follow TCP stream. So here I can see this is my password. So I can easily capture the password and I can read that. So I need to make it that if my password is moving from one location to another location or it's going through different routers, it should be secure. So because Telnet is unsecure, we already find it out. How? By using Wireshark tool. Now what we are going to do, SSH is used for secure CLI. Okay. Now SSH has two versions. SSH versions. SSH version 1 and SSH version 2. Basically, when the router generates a syslog message with 1.55, this means SSH version 1 is enabled. So we will see it through the CLI that how it's look like. And if it's showing us 1.99, this is version 2. So make sure you will remember this thing. This is really important. That if 1.55 is there, this means version 1, and if version 2, this means 1.99. So the router will generate a message like this: SSH 1.99 is enabled, something like that. So you should know, okay, 1.99 stands for SSH version 2 and version 1 stands for 1.55. Now what is the difference between these versions and how the SSH is going to protect our data or passwords? We will discuss about it. So let's discuss about the versions. SSH version 1 and SSH version 2. Now the first thing first, it will generate only the key from 512 to 768, and I will 767, not 768, and it will generate the key of 768 up to our router process from for somehow 2048 or maybe some router that is support 4096, so up to our devices. So let's first discuss about this term. What is a key? Key, it is a mathematical algorithm. It is a mathematical algorithm that performs certain tasks. It is a mathematical algorithm that performs a certain task. So here the size of the mathematical algorithm can be from 512 to 767 in SSH version 1. And for SSH version 2, the size of the algorithm can be from 768 up to our router process. So here are the mathematical algorithm, and the task of the mathematical algorithm is to encrypt the password. So the task of mathematical algorithm is to encrypt the password. SSH version 2 also support AES. That is a new type of encryption that is called Advanced Encryption Standard. Even he support MAC, not media access controller. Here it is called message authentication code. And there are more features that we cannot discuss here because all these features, what is the purpose of AES, and this we will discuss in VPN part. So AES is used for encryption. I can just say now encryption. It is used for hashing, that is called integrity. Whether my packet is changed or not. So it's work like this. This is something. Yeah, it's like this. This is a packet something like hello. This mathematical algorithm will run over it. This mathematical algorithm with a key size of something like this, anything, with the use of AES plus MAC, message authentication code, and it will generate some random values, something like that. Only this can decrypt this. Suppose this is value comes like dollar $YZ. So if we are going to run this algorithm, it can change it. So that's for now, because AES and hashing algorithm will be discussed in VPN. So now we are going to not go through this, but we should aware about this, that AES is the algorithm that is used for encryption and MAC is used for hashing, that my packet is changed or not. Suppose during the transmission I am sending hello. What if someone is changed from hello to bye and send it? So I need to make sure if I am sending the hello should be get it at the, and if A is sending a hello, so it should not become bye, it always become hello. So this is done by this MAC and AES. AES for encryption, that no one can read this packet. So now I'm not going to cancel it because I need it for the reference. Now how to how to enable SSH. Three methods. There are three methods to enable SSH. The first one, basic method. In basic method, what we are going to use, we are going to use a hostname, a domain name, and a command that is called crypto key generate RSA, because we didn't study about this thing, that in CCNA, that what is the use of these two. What is the use of these two things? These are used to give a name to the key, because by this command that perform cryptography, for what is the use of cryptography? For something encryption or something? No, I'm saying to generate a key, perform cryptography to generate the key. And what is the algorithm I should use to generate the key? There is the algorithm RSA. R means reverse Shamir element. So this is the algorithm that we are going to use to generate the keys. So this is a classical method. So now let's verify that these are the two fields that are used to give a name to the key. So first we will use this classical method. This is my topology. I'm going to use on this. The first one is host name, any name, router. Let me take it cisco.com, and the command crypto generate RSA. Let me take the size of 1024. It's like between 768 and up to something, so we can say. So he's saying SSH version 2 is enabled. How we can find out? By using 1.99. So I mentioned it. Okay, I delete that, but let me write it again. If you see SSH 1.55, think that this is SSH version 1, introduced in 1995. Let me mention here also 1995, and it was introduced in 1996. And SSH version, if it's saying 1.99, think of like this: SSH version 2, 1996. So SSH version 2 means 1.99. So 1.99 means SSH version 2 is enabled. The command to view show crypto key my pub key RSA. So this is a key. This is the key and the name of the key, because I told you in my slide that this is used to give a name to the key. So let me verify this thing by showing you that I gave a host name, that is router, and domain name cisco.com. So the key name is router.cisco.com. Okay, this is my key. So let me tell you about these things, like show me the cryptographic key. What is the meaning of this my pub key? So I run a command that is crypto key my pub key RSA, because I run the command crypto key generate RSA. So that is I'm showing here that show me the keys who has been created by running the algorithm RSA. So I am referencing here that only show me the keys that are used by the RSA or that is created by the RSA algorithm. So let's discuss about this thing, my pub key. Let's derive this word and create it my public key. My public key. So my public key stands for key pair. It is a part of a key pair. What is a key pair? So as I run a command that is crypto key generate RSA, crypto key generate RSA, it is used to generate a key pair. It is used to generate a key pair. As we heard about pair, pair means two. Two. What are two? That is public key and one is private key. Okay, public key and private key. Okay, now crypto key generate RSA. It will generate a pair of key. Okay, a pair means two. One is public key, one is private key. What is public key? What is private key? Okay, we will discuss that public key. It is shareable. You can share it to anyone, and private key non-share. Non-share. So what is the scope of this? Think of like this. This is a lock. Okay, this is a lock. That means because it's not look like a lock, so I'm putting a name that this is a lock and this is a key. Hmm, something like this. So this is a key. So we will put this key into this lock and lock it. So this is called public key. And who will open this? No, this cannot open it. So we have, there is another key. I know my drawing is very bad, but just try to understand that I will use this lock. Suppose I have something like a briefcase. This lock is on briefcase. So I will lock this briefcase by using this key one. That is public key. I will encrypt my data with this public key. And who can decrypt it? My private key. So we can derive it that anything that is encrypted with public key can be only decrypted with private key. Anything that is encrypted with public key only decrypted with the private key. So now what we are going to do, we will use this algorithm to encrypt the data, encrypt the data and to decrypt. Sorry for the disturbance. To decrypt. So what I'm saying that we have two algorithms. So basically we have two instances of algorithm. This is the first instance and this is the second instance. So the first instance will encrypt the traffic. So any traffic that is coming towards, if you want to send me a hello, I will send you my public key. You will encrypt my data, or you can encrypt your data. So let me derive it through the example that is more clear. Let's suppose this is a PC, okay, and this is a server. They want to perform SSH. How the algorithm will work? A router already running SSH, which means he has a public key and private key. As our previous discussion, this is share and this is non-share. So as I put here the commands for SSH-L means the login name. I'm saying the login name is maybe Cisco, and to whom I want to perform SSH, maybe some the IP address of the server. So as soon as I type this command, this server will push his public key towards me. This server will push the public key towards me. So I will get the public key. Now, as I type the password, as soon as I type the password, my password is encrypted with this public key. Password is equal to public key encryption. So, as I got the password, sorry, as I enter the password, my password is encrypted with the public key. Now, as per our discussion, that anything that is encrypted with the public key, that our password is encrypted, can only decrypt it with the private key. So, you can decrypt it the private key, the server's private key. So it will send it towards the server, and server can decrypt this password with the private key. So this is a high level overview about PKI. This topic is going to covered in PKI, that is public key infrastructure. Public key infrastructure. So we will discuss in depth about these things. So that's why I'm giving just a high level overview about PKI. This is very high level overview that we have two keys. So just revise it for us for like 10 seconds, that if I run the command crypto key generate RSA, it will generate a key pair, public key and private key. Okay, send to the client. Client will enter the password. Client enter the password, gets encrypt with public key. Then server private key can decrypt it. So this is the algorithm. So now we will discuss about the things that what are my outputs. So this is the key. So now we get it why we are using the host name and domain name. So next thing is about the versions 150. How to delete the previous keys. So we are going to use crypto zeros RSA. This is the command that is used to delete all my RSA generated keys. So I would say yes. So we learned the first method. We learned the first method that we are going to define a host name, a domain name, and crypto key generate RSA. Second method. The second method is using a command crypto key generate RSA. Okay. Rather than defining a host name or domain name, I will give a name here, label Cisco, and the size of the key. So this command means perform cryptography, generate keys. I am telling him to key generation. Use which algorithm to generate the keys? I am saying use RSA algo to generate the keys. Okay. And after the generate key is generated, give a name and size of the key. What is the size of key? Okay. So let's try to run this command. First check it whether my keys are not there or not. Show crypto key, my public key, RSA. One more thing, you cannot view the private keys. You cannot view the private keys because they are put in a kept secret. So crypto generate, use the RSA algorithm, give a name to the key that is Cisco, and the size of the key should be 1024, and my keys are generated. This is second method. 1.99, this means SSH version 2. Okay, the next, let's go for the next, the third method. The third method is a short and a simple method. IP, HTTP, secure server. Why we are, what is the use of this? If we need to perform HTTPS, we will enable this method. It uses the same concept of PKI. So for the PKI, we need to have public key and private key. So this command will generate the public and private key pair. So let's first delete the keys. The command is crypto zeros RSA. You want to delete? Yes. So I don't have any key. Show crypto key my pub key RSA. So I just need to type the command IP. Okay, I forgot to show you what is the scope of the label command. So let me run this again. That the label means giving a name to the key. So show crypto key my pub key RSA. So here the label is defining just a name. Here the Cisco, because I gave a name here, label Cisco, that's why I'm defining the name. So you can easily figure it out. Label means giving a name to the key. Show crypto RSA. Now I will run the command IP HTTP secure server. It will by default generate on 1024. SSH version 2 is enabled. I can view it. Show crypto key my RSA. Key name self signed. So we can also use this. And there's a difference between these things. This and this. These are both public key. These are both public key. Now as soon as you see a dot server, see there is a name EP and dot server. Dot server means this is the key that is used by the SSH. So this public key is going to be pushed over the client. I'm going to send this key to the client. This is used for the VPN purpose. When we are going to perform the VPN, we will discuss about it. And private keys, we cannot view the private key. Now, crypto zeros RSA. So we don't have any key. Show crypto key my pub key RSA. So we don't have any key. So we will use. Let me tell you the method how to start SSH version 1 and 2. So if I give him 590. So please try to focus on this thing. This is the most important part of this nugget. So I will copy this thing. That what he is saying. He's saying something that if you want to enable the SSH version 2, if you want to enable the SSH version 2 that we already discussed, it should be at least 768. Means it should be start from 768. Start from 768. So RSA key size needs to be at least 768 bits for SSH version 2. This means if I put 761, SSH version 1 is enabled. So let me show you some unique thing that if I put crypto close RSA, I'm deleting the keys, and if I change the size to 760, and let me tell you one more thing that 1.55, this means SSH version 1 61, it will enable SSH version 2. Oh, you got the message. SSH 1.99 has been enabled. But here it is showing us that RSA key pair needs to be at least 768 bits to enable SSH version 2. But I gave 761 and he is enabling SSH version 2. What is this? You will think that this is something wrong. No, no, no. Everything is perfect. Everything is perfect. Because here he was telling that RSA key size needs to be at least 768 bits for SSH version 2. And if I gave 761, he's enabling again SSH version 2. This means he needs to be changed from here. The size should be 761. No, this method is called KEYAppend. So we will discuss about KEYAppend. This is a key. Suppose this is a key. So these are the keys. These are the mathematical algorithms that are written. Okay. By definition, let me copy this definition. So this definition is saying like this. But actually this topic is called key append. He knows that RSA SSH version 2 is enabled from 768 bits, but a user gave us 761. How many bits were left? 768 minus 761. Only 7 bits. I will add by myself. I will add by myself. So he will add some garbage value. This value is called KEYAppend. This is some garbage value. Just to enable SSH version 2, because SSH version 2 more secure than SSH version 1. So to enable SSH version 2, he will add some random bits like some garbage value, just 7 bit, so that he can reach to 768 and can enable SSH version 2, which is more secure. So this can be happen only from 761. So theoretically it is saying 768, but practically if you give from 761, it will enable SSH version 2. So my SSH version 2 starts from 761. So if you give any 761, it will add some plus 7, that is garbage, and make it 768, which is going to be SSH version 2. So if you give something crypto, so if you give something 765, then also it will enable SSH version 2. Now he needs to just add 766, 78, only 3 bits. But if you give 760, 760, he will enable SSH version 1. 1.55 means 1. So the last point is 761. Now let's try to perform it. Line will device 0 to 4. Login, local. Let's give a username. Cisco password is Cisco. So on this I will just say SSH. I want to define the login name. The login name is Cisco. For which router? The router is 12.1.1. Okay, I can use one more method. That's a really good troubleshoot. Let's first check whether we have a connectivity or not. We have a connectivity. So why he reject this thing? Why? What is the reason? Let me tell you first all the commands. Login name is Cisco. Here we can define it. Which encryption algorithm I want to use. MAC that I've already discussed. Which port I want to connect and what are the versions I can, like version 1 or 2, and the IP address of the server. So we don't need to be panicked. Just go to again line with device. This time just say password is Cisco and perform login. Then let's try again. But this thing is not going to work for the SSH. This is I'm just doing for the Telnet purpose. It is working. So now let's check whether my SSH is enabled or not. Show crypto key. So crypto key, my pub key, RSA. So this is our SSH version 1. This is SSH version 1. Why? Because SSH version 1 is enabled. So by default, so it's a really good troubleshoot that if someone is going to run SSH version 1 and if you tell you about that enable this, let's try to log in, you don't know, you are not able to figure it out that whether it is version 1 or 2. So if you try to put it this command, it will reject it because by default it is working on SSH version 2. If you are not mentioning anything here, this means this is SSH version 2. So I just need to go to here and type crypto key zeros RSA. Let me delete all the keys and let me generate SSH version 1. Sorry, SSH version 2. Now, why it's taking time? Because R1 is sending a key, a public key to the R2. So it works. Okay, I put the wrong password, but let me just start the Wireshark also. Okay, no issue, just stop working. Start the Wireshark, change the port number. Sometimes Wireshark is going to be crash. What is the password? Forward. Show run section username. Okay, the password is Cisco. I was typing Cisco 123. So this is the password. I forgot. I thought it's Cisco 123. So what we have learned, we learned about SSH versions 1, SSH version 2, PKI, that is public key infrastructure. Okay. The next thing we learned, that is called KEYAppend. So that's for now. See you.